All right, year 12s. We have another question here. This is example 3 on page 563 of 15A, which is Introduction to Bernoulli Sequences. All right, so this is, I'd say it's similar to example 2 in our last video, but it's what we call a cumulative probability question, and you'll see why in a second. The probability that a person currently in prison has ever been in prison before is 0.72. Find the probability that of 5 prisoners chosen at random, at least 3 of them have been imprisoned before. Correct the 4 decimal places. Okay. I think when choosing or when attempting these questions, it's really valuable to list the things that we need. All right, this is a Bernoulli problem. So what do we need? Well, first thing, we need to identify the random variable that we've got here. So big X. Of the random variable that we're thinking of, we need to be able to find the random variable of interest to us. What is the question asking us to find? The number of items and the probability. With this information complete, we can go to our formula, and depending on what calculator you've got, it might just be a different strategy. Okay, so with this question, what is the random variable? The thing that can change, right? What is it? Well, it's the number of prisoners who have been in prison before, right? Let's highlight the random variable. I'll use green. A person currently in prison has ever been in prison before, right? It's the probability that, and that's the random variable. So someone being in prison that's already been to prison before, right? So we'll write that right here, okay? So let's do it. Number of prisoners imprisoned before their current imprisonment. Right, the next part, little x, or the algebraic x, is the random variable that we're interested in, okay? So out of the total number of options with the number of prisoners imprisoned before, what number are we interested in? Well, let's first understand what are all the options for the number of prisoners that have been imprisoned before. Well, it says here, find the probability that of 5 prisoners chosen at random. Yeah? So of 5 prisoners chosen at random, which ones are we interested in? Or how many are we interested in looking for? It says, find the probability that at least 3 of them have been imprisoned before. Yeah? At least 3. So we're going to write at least or greater than 3. At least. So that's as equal as well. So at least is equal to or greater than 3. So basically that's 3, 4, and 5. They're the numbers that we're interested in. And really, it's going to be this. 3 plus 4 plus 5. And this is where this question differs, because these probabilities will cumulate, or cumulative. And so we're going to find the probability of each of these separately and then add them together. Okay? Okay. All right. N, number of items, or number of things that we're going to be choosing from. Well, there are 5 prisoners. So N is 5. And P, which is the probability of success, right? A probability that a person currently in prison has been in prison before, is 0.72. Okay. I think we've got it here. We've now got all the information that we need. Let's go ahead and use our formula here. To attempt to answer the question. But we're going to slightly modify it because we're not looking for the probability that our random variable is equal to some specific number. We're interested in our random variable being greater than or equal to 3. Hope that makes sense, because we're interested in at least 3 of these prisoners having been imprisoned before. What's the probability of choosing 5 random prisoners and at least 3? Not just 3, but 3 or 4 or 5. So at least 3, okay? So now let's go ahead and just substitute everything that we know. So let's just recap here. Last video, I didn't explain this. I just wanted to get through that first example, just get you into the rhythm of things. This is, and I'll go over here. When you see a number on top of another number like this in these circular brackets, we can say that it's called the binomial coefficient, okay? What it is it's n choose x. I'm going to write it like that. That's how we say it. N choose x, okay? Of n number of items, we're choosing x number of items from that list, okay? So in our particular example, let's go to it. So this will equal, and I'm going to do it in blue now with our answer. N, let's just kind of just zoom out a little bit. N will be 5. So of 5 items, or of 5 prisoners chosen at random, we're looking for, well, the first number we're going to start with, because remember it's greater than 3 or equal to. We're going to look for the probability of 3 being selected that have been imprisoned before, okay? And so we'll multiply that by the probability, which is 0.72. We'll raise that to the power of, I'm just looking here and here at the moment, raise that to the power of x, which is 3. That's the random variable we're going with, multiplied by 1 minus p, which is 0.72, to the power of n minus x. All right, so what that is the number of items, we had in the beginning, which is 5, minus the variable that you're choosing to go with for this question. So it's 5 minus 3 at this stage. Okay, what we've done so far is we've expressed the probability of choosing choosing exactly 3, right? So let's go ahead and underline this. This here, the probability that x equals 3. That's this part. But again, we're only interested in, we're interested in equal to 3, but 4 and 5, right? Greater than 3. So let's do the same thing. We're going to repeat this process, and to find the probability when our random variable is 4. So let's do that. All right. Add. Okay. Next. So using the formula, the same formula as before. So this one here. We'll start here. So n, in our case, it's still 5. But now our variable that we're interested in, right, our random variable of interest will be 4. Multiplied by 0.72 to the power of 4 this time, times 1 minus 0.72 to the power of n minus x. So 5 minus 4 this time. And so what we've done here is we've calculated the probability that our random variable is 4. I predict I'm going to run out of room, so let's go ahead, shove across a little bit. And we'll add that now to the probability of our random variable being 5. So 5, and now our random variable of interest is 5. Multiplied by 0.72 to the power of 5, multiplied by 1 minus 0.72 to the power of 5 minus 5 this time. And so we have just calculated or expressed the probability that our random variable is 5. So if the question just asked us, find the probability that of 5 prisoners chosen at random, 3 of them have been imprisoned before, we would just put this into the calculator. But again, it's at least 3. So we need to consider 3, 4, and 5, which we've done. So from here, it's a little bit complex. If we have a graphics calculator, which will come up in either another video or later on in the year, I can show you that. But we're going to use just a scientific calculator, which is fairly straightforward. The only thing that I think you may have difficulty with right now is this, and this. All the other stuff is fairly straightforward. You can just chuck it into a calculator. Now think back to our previous video. I showed you how to do this, but each of these relate to this formula, the binomial coefficient formula. Just tells us how many combinations there are if you choose X number of items from N number of items, okay? So what we go ahead and do is we do the factorial of N, we divide by the factorial of X multiplied by the difference, or the factorial of the difference between N and X, okay? So let's find some space and we can do that for this, this, and this, okay? I think what I'll do is I'll go to the new page. I'll copy this so we still have our working. Copy, paste. This is what we're working with. We'll take our formula. We'll plug it up here. And remember, we're just trying to work out our final answer now. We have a pretty straightforward equation or problem here. So let's go ahead and do it. All right, so 5 choose 3 will be 5 factorial, right, using the formula here, over x factorial, which is 3 factorial, multiplied by 5 take 3 factorial. Yeah, save some room here. Times, and then I'm just simply going to copy this. Oh no, didn't mean to do that. Like that. Okay, so this is simply this, but I've just expanded this so that we can do it in the calculator. Okay. All right, let's keep going. So we're going to add that to, all right, again, 5 factorial over 4 factorial this time, multiplied by 5 take 4 factorial, multiplied by, and then we'll just take this bit, copy it, paste it. So just to recap, this is the probability of X being 3. Copy. And this is the probability that X is 4. Let's just extend that line a little bit. Okay. we just got one more, and it's x equaling 5, which we'll just do a little bit below, down here. Okay, so it'll be 5 factorial over 5 factorial multiplied by 5 minus 5 factorial times, and then I'll just copy this, paste that there, and that there, is the probability of x equaling 5. Okay, so we're up to here now. We can put that in the calculator. I will put the camera on to show you how to do this, and that'll tell you how to do this and this as well. Okay. Let me just take my calculator out. All right. There we go. All right, I'm happy with that. So the first part is 5 factorial. So 5 factorial. We're now they're going to divide that by. I'm going to put all this in brackets now. All right. So it'll be 4 factorial. I beg your pardon, 3 factorial. And then we're going to do what with that? We're going to multiply it by, bracket again, 5 take 3 factorial, which we know is going to be 2. You can do 5 take 3, but you know it's going to be 2. So just put 2 in, and then 2 factorial, bracket again, and we've got 10 here. Okay, so that's 5 factorial divided by, all in brackets, 3 factorial times 5 take 3 factorial. That gave us 10. Okay, so let's cancel that. Back to our page. And we know this here is 10. Going back to our calculator, let's do this part, or this part, right? 5 choose 4. Yeah, that's the correct language we're going to use. So let's now go to camera. All right, get rid of that. So 5 factorial divided by bracket 4 factorial times the difference between 5 and 4, which will just be 1 factorial. Close that bracket and then close the big bracket, and we have 5. So that's 5. Last one we're going to do will be this part here. I wonder what that's going to be. 5 choose 5. Whoops. Okay. 5 factorial divided by, bracket, 5 factorial times, well, it's going to be 5 take 5, which is 0 factorial. So we have an answer of 1. Makes sense. So that's 1. Okay, so all we have now is, and I'll read it from left to right, 10 times 0.72 cubed times 1 minus 0.72 to the power of, well, that's 2, plus 5 times 0.72 to the power of 4 times 1 minus 0.72 to the power of 1. Don't forget to add this to the last part, which is 1 times 0.72 to the power of 5 times 1 minus 0.72 to the power of 0. If you put that into the calculator, you should get, and I'm expecting, 0.8624. And so that answers the probability, let's do this, the probability that of 5 prisoners chosen at random, at least 3 of them have been imprisoned before. Correct to 4 decimal places. Right there. All right, long video, but I think that's helpful. Please email me if you have any other questions. Thanks, bye.